In today's class, we will learn logic programming. We looked at this predicate propositional logics. Logic programming, it is based on first order logic. Mm, Anyone remember what is first order logic? Hmm. So, when inference rules are added to the first order predicate calculus, it becomes first order logic. Inference rules. How to derive or deduce new statements from the existing statements. It is known as first order logic. In this logic programming, actually it was first introduced by Kowalski in 1974 and Kolmogorov in 1973, and it is based on first order logic. In logic programming, a program is a collection of program clauses. A clause in FOL is represented in causal notation in logic programming. Causal notation is written in this form. P1 up to Pk, this reverse arrow, N1 and NP, where Pi is within I less than or equal to 1, less than or equal to, no, I greater than or equal to 1 and less than or equal to k. Pi's and Ni's are j less than or greater or equal to 1, less than or equal to t. These are negative literals. P's are positive literals. And n's are negative literals. These positive literals followed by negative literals having a reverse arrow in between them is known as clausal notation. In logic programming is written in this clausal notation. How to convert a clause into clausal notation? To convert a clause into clausal notation, first we have to look for all the literals and identify positive and negative literals. They are separated by the arrow. A clause in first order logic is a closed formula, and it is of the form L1 union L2 and so on up to union LM, where each literal mm, k literal k is greater or equal to 1 and less than n. This is a clause in FOL. Each L is a literal, and each one is universally quantified. In FOL, I'm talking about FOL, first order logic. How to identify that? What happens in this logic programming is P1 or P2 or 2PK or uh, this one is equal to P1 or means all positive literals, not not n all negative literals, where k plus t, where m is equals to k plus t. M is this. What is m? M, we have k plus t, where k are positive literals and t are negative literals. M is the total number of literals. There are positive literals p, negative literals n, and together we get literals. However, in this logic programming, all the literals must be having in any one of the forms, either positive or negative. We can have positive literals p1 and up to pn or pm, back arrow n1, n2 and up to nm. These are let us take pk and nt, pk and nt. These are the total number of literals. P1 union, P2 union and up to Pk, or not n sub I or up to nt. This is logic programming. And this logic programming is based on FOL. FOL is first order logic. And in logic programming, programs are written as a collection of program clauses, collection of clauses. A clause is written in the form P1 up to Pk, N1 up to Nt, where Pi, where I is greater or equal to 1, less than or equal to k. These are positive literals. N, j, j is greater or equal to 1, less than or equal to t. These are negative literals. Now we'll understand conversion. Conversion of a clause into clausal notation. What is clausal notation? This one. Consider that L1 up to Lm, this is equal to saying Pk P1 union up to Pk union not n not n1 not nt, where these are literals, these are positive literals, these are negative literals. M plus t, m is equals to k plus t, where m is equals to k plus t, and pj is equals to j greater or equal to 1 less than or equal to k, and j is equal to not equal to, it's just the range. How this can be written as P1 union PK, or not N1 union not NT. This can also be written as, which is equal to P1 union PK union not N1 union NT. This is equal to N1 and N2 and NT, implies P1 union up to Pk. How you got this? Because we know that P implies Q is equal to not P union Q. Because of this equivalence rule, we obtained this equation, which can be written as P1 or Pk. This is, here n implies P is there, no? So this is also like n implies P written in reverse direction. This can also be written as, or P1 without parenthesis. All right, student. This is how uh, this one is known as P1 N1. This is known as implied by. Implied by. This is implies. In forward direction, it is implies. In backward direction, it is implied by. N is known as antecedent and P is known as consequent in if when it is in this format. In this format, N is antecedent and P is consequent. In any implies equation, when you say P implies X implies Y, X is known as antecedent, Y is known as consequent. And when you just reverse it, X is implied by Y. No, it should be reversed, means it should be Y implied by X. This way. X implies Y means Y implied by X. Alright, there are three basic statements in logic programming. First one, rules, facts, queries. And these are known as special form of clauses. A logic program is a finite set of program clauses. Logic program is a finite set of clauses. What is a program clause? It is a clause that contains one positive literal represented in this form. It is known as conditional clause. Okay, this is known as conditional clause. Why it is known as conditional clause? Because the interpretation of P is assumed to be proved only if n1 up to n are proved. When these negative clauses are proved, only then this positive clause is proved. Therefore, it is known as a conditional clause. Program clause is also known as a rule. Then a clause does not that does not contain a body is called as a unit clause. Just P implied by. There is nothing here. This is known as a clause that does not contain a body. A clause that has empty consequent is known as a goal clause. If there is no P and if there is only N, then it is known as a goal clause. A clause with empty consequent and empty antecedent is known as empty clause. Let us look at an example. These are the rules. X is a mother of Y if X is mother of Z and Z is mother or father of Y. So how are you writing these rules? X is grandmother of Y. X is mother of Z. Z is parent of Y. Based on these relationships, these rules have been framed. Then facts. These are the facts. What is the fact? Mary is mother of John. Tina is mother of Kittu. Goals. What are the goals? Goal is Mary a grandmother of Mike? This we have to find. Is Mary a grandmother of Mike? We have to check in this. Is Mary grandmother of Mike? Mary is mother of John. John is father of Mike. Therefore, this statement is true. Example, check whether the ground goal Mary is a grandmother of Mike is true. How can you prove this to be true? We are proving by contradiction. When we are proving by contradiction, there is a need to add not. Okay, we add not, and how to prove that Mary is a grandmother of Mike? By contradiction. Okay, add not of the goal to this program uh, logic is there, no logic program, to get a new set S, where S is defined as PL union not G. What is G? Goal. Goal, you are making it negative, not G. What is PL? PL is all our those clauses, program clauses, program logic. Okay, so that program logic union not goal. Grandmother X. These are all you if you observe here. These are all clauses, program clauses. These this one along with this goal. What is goal? Mary grandmother of Mike, and you are negating it. So Mary is not grandmother of Mike. Through resolution, you are creating a tree, resolution tree. X given Mary, Y given Mary. How you got this? From 1 and 8. From clause number 1 and clause number 8. Here, this is clause number 1 and clause number 8. From this, what do you understand? If you are placing, you are substituting Mary for X, this is X. You are substituting Mary, means X given Mary, Y given Mike. This is Y, Y given Mike. Alright, when you substitute that, what do you get? You get that this grandmother and this grandmother eliminated because of this is positive and this is negative. What is left? Left is not mother xz or not parent zy. But we know that in place of z we are placing Mary, and in place of y we are putting Mike. Okay, we got this. And then now from this statement means this clause and clause number 4. What is clause number 4? Is Mary mother of John. When you combine both, then you are what happens from this? You get a value John for Z. For Z, you get a value John. And now not mother and mother get eliminated. What is left is not parent. Parent, uh, John, Mike. This clause with the clause number 2. What is there in clause number 2? Parent XY union not father XY. X is John, Y is Mike. Parent plus this parent, not parent, and this parent, not, just parent and not parent get eliminated. What is left is this not father, John, Mike. From this two, this clause and clause number 7, John is the father of Mike. What is obtained is X. Means this clause and clause number 7. Clause number means this both get eliminated. This is not father. Clause number 7 is father. There is nothing left. It is cross. Because there is nothing left, it can be proved by contradiction that Mary is actually grandmother of Mike. Okay, we can conclude that Mary is grandmother of Mike. There is another problem where X is grandmother. We have to check the non-ground goal. This is a non-ground goal where we have to check as X is grandmother of Mita is true or not. To check that, we are starting again with these clauses. Here we have got this program logic. This program logical clauses along with the uh, this goal, and this goal is negated because we want to generate this tree through contradiction, and because it is not grandmother and not grandmother get eliminated, we get not mother not parent, and from here and here mother and not mother would be eliminated, leftover is not parent. From here and here, three third, what is there in third? Parent and not mother. Parent and not mother. Parent and parent would be eliminated. Parent and not parent gets cancelled. And what is left is not mother. Not mother, Kitu is not a mother of Mita. This one and sixth one. Sixth one is Kitu is mother of Mita. Again, this is normal mother and this is negated mother. L both eliminated. Leftover is X. Alright, so this is also proved. This is proving by resolution tree through contradiction. Next one, resolution method. Resolution is a powerful inference technique which takes two clauses as inputs and produces a clause as the output. And the output clause is called a resolvent. If the resolvent obtained is a fact, then it is said that we have proved a fact. If the resolvent consists of empty clause means this one, x, just x we obtained, no, that is an empty clause. And that is obtained empty clause when there is a contradiction. There are three important cases of resolution: backward chaining, forward chaining, and rule collapsing. In backward chaining method, one of the clauses resolved is a goal clause. Backward chaining, you start with a goal clause. And in forward chaining method, one of the clauses is a fact. You start with a fact. In rule collapsing resolution method, two rules are identified in such a way that one rule has a positive item, another rule has a negative item. Whenever there is a rule collapsing, that would be eliminated. Like this is not mother and comma mother. Okay. We have got one positive and one negative. Examples are given here. Background chaining. This is in clausal form. This is in logic form. In clausal form, we have P implied by Q, comma R, and this is implied by P, and the result of resolution could be implied by Q, comma R, these two. And forward chaining, we start with one of the clauses is a fact in this clausal form. This P is implied by QRS and there is R. R is a fact. And the rule of resolution is P is implied by Q, comma S, and this could be written in logical form as P or not S or not R or not Q, not R, not S, and just R. because this is by contradiction. So, and no, when this P implies Q is written as P not P or Q. So that this through this one you are converting into this form. Rule collapsing. Um, Rule I would be replaced by uh, R in its body. Some some things when both are common, they get replaced. So this is clausal form P implied by QRS, R implied by TUV, and the result of resolution is P implied by QTUVS. And in logic form, it is written as P or not Q, not R, not S, like this. R, this is not T. Your implied by is replaced by or, and then these normal literals would be negated, and then the result of resolution would be P Q T U V S. This all negations, when you change it into this implied form, would be eliminated. Okay, that's it. And then tomorrow we will start this. This chapter is not there in the syllabus. Perhaps the next part. I'll open the next part, and in tomorrow, not tomorrow, next week, we will start with the next part, which is knowledge representation. Any doubts, students?